right, let's take a look at this second example. So now we're going to bring in a situation where we have angles involved. So we're going to have to resolve forces into components. Let's go ahead and set this one up. A horizontal beam in the figure to the right weighs 150 newtons and its center of gravity is at its center. First, make a free body diagram of the beam, then find the tension in the cable, and then part B, find the horizontal and vertical components of the force exerted on the beam at the wall. All right, so the first thing we want to do, draw that big free body diagram. So let's go ahead and do that. So they did say that the weight was acting at the center, so that's 150 newtons, they said. There's also this barrel hanging on the end at 300 newtons. There's a cable acting on it. Whenever there's a cable, there's tension acting along the cable away from the object. And then the wall. Now, they don't tell us, is the wall pushing up? Is the wall pulling in? Is the wall pushing out? What is it doing? And so we have to kind of think about this. All right, so tension is pulling the beam toward the wall. So that means in order to have this not accelerate toward the wall is going to have to apply a force back. Okay? And to figure out the why, what I'm going to do is I'm going to think about holding this end constant. This will be my axis of rotation. And so the 150 newtons is trying to turn it down, so that means the wall must be trying to hold it up. Another way that I like to visualize this is I imagine what would happen to this beam if all of a sudden, like, it was released from the wall. What would happen? Or if the wall disappeared. And so you would see that if this wall disappeared, this tension would pull this beam back toward the wall and it would just swing down like that. So if you can imagine that, that'll help you to kind of figure out, okay, I got to counter that. That's what the wall is doing. It's countering that motion. If you get these wrong, so let's say I chose Fy as down, that's okay. What you'll end up with is you'll get a negative number for Fy. And if you get that negative number, that's a hint that possibly you chose the direction wrong. Sometimes it's other errors, but sometimes it's just, hey, I put the direction up and it was actually pointing down. All right, so the next thing we're gonna do, we've generated our free body diagram, mg at the center. Okay, we gotta label our distances. So this whole thing was 4 meters, so that makes this 2 meters and this 2 meters, okay. We need to choose an axis of rotation. So ideally, I want to choose my axis of rotation to eliminate unknowns, and I have 3 unknowns, fx, fy, and tension. So I'm going to go ahead and choose my axis of rotation right here, because then Fy will produce no torque. Now Fx wasn't producing any torque in the first place because it's parallel with the beam, so I didn't have to worry about that in my torque equation, but this gets rid of Fy as well. All right, so now I need to identify the torques as having positive or negative direction. I do have one extra little bit I have to do with tension here. And so tension I need to resolve into components. So I have a T cosine theta and I have a T sine theta because I need the perpendicular part of that force to be the one that does the torque. And this is all applying over here at this point. All right. So I see that the 150 and the 300 newtons, those are both causing a clockwise rotation. So they are both going to be producing negative torques. Or I could think, oh, they're to the right of the axis rotation, so their directions of their forces are right for their directions of the torque. So they're both pointing down, so they get negative torques. T sine theta is pointing up, so it's going to cause it to rotate counterclockwise or have a positive torque. Okay. Next, they need to generate those 3 equations. So I'm going to sum up the forces in the x direction, set equal to 0. So I have Fx minus T cosine theta equals 0. In the y direction, we're going to have Fy plus T sine theta minus 150 minus 300 equals 0. And so the reason we need the torque equation here is I have 2 unknowns in each of these equations, tension and Fx in the first one, tension and Fy in the second one. So a good thing for me to choose my axis rotation here is this is going to allow me to find tension. And if I know tension, I can find Fy. If I know tension, I can find Fx. If you would have chose it somewhere else, maybe like over here, you would have found Fy, and so you would have used Fy to find tension, and then you could use tension to find Fx. Totally fine. Multiple ways to solve it. So let's go ahead and generate that torque equation. So the sum of the torques is equal to 0. So I have T sine theta times 4 minus 150 times 2 minus 300 times 4 equals 0. Now notice this time, did I write Fy times 0 in my torque equation? No, but I do know that that is producing 0 torque because its distance from the axis rotation is 0. So that's why I'm not including that Fy. So at this point, I now need to solve this. Now I do need to deal with this theta over here. So what we're going to do for that is, because this is our 3, 4, 5 triangle, I believe it's like, what was it? 3, 4, 5. This is our theta. So the sine of theta in this case is going to be opposite over hypotenuse, so 3/5. And the cosine of theta is going to be adjacent over hypotenuse, so 4/5. So I'm just going to substitute in 3/5 wherever I see sine of theta and 4/5 wherever I see cosine of theta, as opposed to solving for the angle and substituting in that way. So let's go ahead and solve for this. So now I have T sine theta times 4. And so 150 times 2 is 300. 300, and then over here I have, what, 1200? So 300 and 1200 makes 1500. So let's move that over. So now I have T is equal to 1500 divided by 4 times the sine of theta, which was 3/5. Plug that in your calculator, and you should get 625 newtons. All right. Now that I know tension, I can plug that back in and find Fx. I can plug that tension in and find Fy. If you wanted to choose a new axis of rotation to find Fy, that would be fine too. So let's go ahead and do that. So Fx is going to be 625 times the cosine of theta, which is 4/5. And so Fx is going to come out to be 500 newtons. Fy over here, so let's go ahead and do that one. So Fy is going to be 150, and 300 is 450 minus 625 times the sine, which was 3/5. Fy comes out to be 75 newtons. Now the fact that these both came out to positive numbers, that means I chose my directions properly in my free body diagram. All right, so there's our example for a situation where we got some angles, a few more torques involved.